Hi, my name is Robbie Lieber. I'm the lead product engineer on NevadaNano's MPS Refrigerant Gas Sensor, and I'd like to introduce you to the sensor today. So just to give you a little bit of info about the sensor itself, it provides a very accurate response with a reliable detection of various A1 and A2L refrigerants, including R32 and R454B. The sensor has a 10+ year calibration interval and also a lifetime. So it delivers an industry-leading performance and the lowest cost of ownership. So we'll go ahead and start with a demo of some environmental transients, and then we can go ahead and roll into a balloon pop demo. So for this demo, we're gonna go ahead and do an environmental transient. For many sensors, transients are an issue for false positives, and we've spent countless hours here at NevadaNano working to harden the sensor to these transients. So I'm gonna go ahead and blow on the sensor to introduce a heat and humidity transient. And you'll see a spike of over 50% or so relative humidity. And it'll go ahead and just drop right back down. And you'll notice that on the top of the screen there, the concentration remains constant at 0, as it should. So we've been able to do a really nice job of decoupling the environment from analytes. And so we'll go ahead and do one more here. And as you can see, no change to the response. So for a second demo on environmental transients, we'll go ahead and do like a hot and dry. And again, this is a problem area for many sensors and a region that we've spent a lot of time compensating for. So we have a heat gun here. We'll go ahead and apply some heat now. And you'll see that even with a drastic decrease in the humidity there and a spike in temperature, we have no change to the concentration reported. So you can see after the initial spike, it takes some time for the transient to clear out, and that's due to the thermal mass of the sensor. The important thing here is that the concentration remains at 0 while the sensor handles this environmental transition. So this is our balloon pop demo, and we like to use this to show the response time of the sensor. So what we have here is a balloon full of pure R32. Given the volume of this box here, once we pop that balloon, we'll have a volume of about 25% R32 in the chamber. And we've chosen 25% because of the ASHRAE and UL standards. Those kind of specify a maximum set point of about 25% LEL. So we'll go ahead and pop a balloon here. And you give it a moment to diffuse, and we should see a response in about 6 seconds. And there you have it. We're at about 24% LEL, so right in spec. And just to give you a little background there, that balloon was filled with a mass equivalent of about 3.4 grams of refrigerant, or about 0.063% of the refrigerant required to cool an average home in the US. So you'd need about 1,600 balloons to cool the average size home in the US. And then we can go ahead and pull the lid off here. And you'll see the sensor clear out from R32 quite quickly. This is one of the fastest responses you'll find in the industry. You'll find that many other technologies are in the, say, 20-second range. We know that the UL standard requires a less than 10-second response time. So for many of those sensors, they'll be required to drop their set points, which will potentially lead to issues with false positives. For more information on the MPS refrigerant gas sensor, you can visit us online at NevadaNano.com or send us an email at info@NevadaNano.com.